Hi, this is John Fellenstein, Professor Polymer from the University of Akron's Akron Global Polymer Academy. We're part of the College of Engineering and Polymer Science here at the university. We're going to talk about a special polymer today called polystyrene, but I was wondering if you knew what a polymer is. So I have this neat demonstration here for you. Check this out. Sometimes I can catch that. Okay, so a polymer is a chemical formula or a substance that's made up of repeating units, okay? This really, really long chain is what we call one polymer molecule. It's a model, right? Scientists use models all the time to help explain things that they can't see, things that might be too small or too far away. So this one long polymer molecule is made up of several different repeating units that are all the same. These repeating units are called monomers, all right? The monomer is exactly the same in this case, but with our chain, they're different colors. So a polymer molecule can have very, very many different properties, and we can engineer those properties for things that we want to do with it. Here's another example of a polymer molecule. It's just this little plastic chain. In the plastic chain, each of the links is identical, and they connect to each other and they form these long chains. Now in specific polymer plastic materials, these chains can get tangled up, all right? And so they change their properties depending on how we arrange the chains. Alrighty, so now I'm gonna step behind the table. Polystyrene is a type of polymer that's used in many, many products. It's used to mold several different things. For example, food containers, dinnerware, insulated cups for coffee and other hot beverages, coolers, and also structural material to protect fragile electronics and other things when they're being shipped. And as a matter of fact, we have some really interesting research happening here at the University of Akron. And in the next segment, we're going to learn a little bit more about that. So I'm here with Dr. Weinan from the School of Polymer Science and Polymer Engineering. And Dr. Zhu is working on a novel project with one of our very most common polymers known as polystyrene. And so he's going to explain a little bit about the chemistry of polystyrene.
Okay, thank you, John. So my lab at the University of Akron, one of the projects we are working on is trying to use recycled polystyrene for 3D printing. But before I talk about the actual project, I will talk about why polystyrene is special. So you can see on this screen, and this cup is made from polystyrene. If you look inside what is the cup made of, you will see a lot of polymer chains entangled together. And if you look at a single polystyrene chain, it is composed of many repeating units, which are called monomers. So here is a good example of polystyrene monomer. So the red spheres represent the carbon atoms, and the purple spheres represent the hydrogen atoms. So you can see that each monomer composed of 8 carbon atoms and 8 hydrogen atoms. And those monomers covalently connect with each other to form those long polystyrene chain and eventually a bulk material which you can use to make plastic cups, etc. And because of this unique molecular structure, polystyrene also have unique properties. For instance, it has a reasonably good thermal stability and mechanical property. And its softening point is about 100 degrees C. So which means anything that is colder than 100 degrees C cannot soften or deform it. That's why it can be used as a plastic cup for beverage, even coffee. And another interesting property is that although polystyrene is stable against water or drinks, but it can be dissolved in some organic solvent, including benzene, acetone, etc. And now John will demonstrate how to dissolve polystyrene if you need.
I just happen to have a little bit of acetone right here, so hold on. Okay. This is nail polish remover. It's mostly acetone. It's very, very, very volatile, so we have to be very careful with this. But if we take a polystyrene cup, we can dump a little acetone on it and watch what happens. Wait for it, wait for it. Oh yeah. So it's completely gone. But there is some of that material at the bottom of the container. Now, one of the reasons that styrofoam coffee cups are so good at insulating is because that large volume of the cup is really not made up of a large volume of the material, but it's mostly air. And air is one of the best insulators that we have. So we can use the acetone to dissolve the polystyrene cup, but it seems to me like that might not be the best way to get the material back. So Dr. Zhu, what do you think as far as the organic solvents and dissolving this material?
Yes, as John just demonstrated, you can dissolve polystyrene with organic solvents such as acetone, but this is not an environmental friendly or economic way to do it, because the production and use of organic solvents themselves is not environmental friendly, and also the cost is usually pretty high. So as a matter of fact, the polystyrene, if you look at this pie chart, is one of the most produced plastic worldwide per year. It is estimated that this green part is a polystyrene. It is produced roughly about 25 million tons per year worldwide, and most of those polystyrene are not recycled. As a result, they cause significant environmental issues, as you can see on those photos. The waste polystyrene foams and waste polystyrene cups caused a lot of environmental issues. So to solve those issues in our lab, we are trying to develop new ways to recycle polystyrene, such as using them for 3D printing.
Oh, really? Interesting. So it's important to keep that material out of the environment. And do you happen to have some of the materials or the equipment that you're using in your lab?
Sure, we have it here. We can take a look.
So Dr. Zhu, you've brought some of the equipment from your lab here. I was just wondering if you could explain to us what you have and how you're using it.
Sure. So what you're seeing here on the table, this one is the desktop extruder, and this one is the actual 3D printer. So I will explain details, each of them, in the following conversation.
Okay. So we start with a cup that looks like this. It can either be recycled or purchased, right? A new cup. And so we take this and we put it in here, but we can't do that, right? So we have to, there's an intermediate step where we have to turn it into flakes. So how do you do that?
Yeah, so basically this is a recycled polystyrene cup. You need to wash it clean, and after that you need to cut it into small pieces, because this extruder can only use small pieces of polymers. So in our lab, we use a grinder which can very quickly turn this into small polystyrene pieces. But even at home, you can use a scissor to cut it, although it's slower, but you can do that. And after you get this polystyrene, these small flakes, you basically load it onto the extruder. So this extruder basically has a screwdriver inside, and it is also heated up, this chamber, so that these polymer flakes gets heated. And when the screw is running, you will see the filament coming from that side.
So it reheats the plastic, and then it forces it through a heated tube. It melts it and forces it out in the shape of whatever the die is on the end. Is that correct?
Yes, that's correct.
Okay. So Dr. Zhu, can you tell us how we get from the filaments into a finished product using the 3D printer?
Sure. So the filament in John's hand is what we just produced from those polystyrene cups using the desktop extruder. And having this filament ready, we first load the filament into our 3D printer. So this type of 3D printer is called Fused Filament Fabrication, FFF 3D printer. So I would first turn it on, then I will explain how does it work. Okay, so while it's printing, I will explain how does this printer work by using this the slide on the screen here. So it's called the fused filament fabrication 3D printing. Your starting material is a polymer filament. So this filament is transported to a printing head. So this printing head is automatically controlled by the software, so it can move in X, Y direction. And also this printing head has a heating cartridge so that your filament is essentially being melted and then extruded through the very small nozzle at the end. The nozzle diameter is usually about 0.4 millimeter. And with the moving of the printing head, you are depositing one layer of materials on the printing bed. And after one layer is finished, either the printing head or the printing bed is moving up and down so that it will start the second layer. So it repeats this process layer by layer until you get a final 3D object. So you can see what it actually looks like on the 3D printer.
And if I look at this vase in really close detail, I can see really, really fine lines on it. So each one of those lines is going to represent one of the layers that was deposited by the 3D printer.
Yes.
So how thick are each of those lines?
So that basically depending on the diameter of the nozzle. So in our case, the most commonly used diameter is 0.4 millimeter, which means the lateral dimension is around 0.4 millimeter. And in the vertical direction, it's actually higher than that because after the extrusion, it's not perfect like spherical in the cross section.
I see. And how long will it take us to print our object here?
So that depending on the size of the 3D object.
Right.
If you need to print this small object, it can be done in 10-20 minutes, depending on also on the printing speed. But if you want to print a very large object, like an actual water container or a cell phone case, that will probably take 1 hour or even more. So you can see that this is the printing head. It is now moving in the X direction, and the printing bed is moving in the Y direction while it's printing this layer. And this filament is being transported all the way down to that very end, which is a heated nozzle.
So this printer, is this expensive, or is this something that I could buy, online maybe?
No, it's not expensive for this simple 3D printer. So this type of printer is actually the most commonly used for basically every amateur users, and also if you just want to 3D print for fun. So you can purchase this online for less than $500.
Okay, and normally what type of filament is used in a 3D printer like this?
So the most commonly used filament are made from also thermoplastic, including ABS, which is a copolymer thermoplastic, and also PLA, which is another type of polymer. Polystyrene can also be used, but polystyrene, one of the issues with polystyrene is that it's rigid, so people usually don't use it for many applications where you want some flexibility.
So if I try to take this filament and wind it up onto a spool, I'm not going to be able to wind it very tightly because it's more likely to break.
Yes, that's actually a good point. So if you want to use polystyrene for applications that requires more flexibility, you can do modification to polystyrene. For example, when we do the extrusion, we can add nanopolymer, which is more elastic, like rubber. We can mix rubber with polystyrene to make basically a hybrid filament with the same size, but the internal composition and the structure are different so that they are more flexible.
Very good. All right, looks like we're making another one of these vases, and it is almost halfway done. So that'll take another few minutes. So here's our finished product. Pretty neat. I'm wondering if I don't like the way this turns out, can I make it again, or can I reprocess this material? Yes.
So basically, if you don't need this final product anymore, or you found there are some defects on it, it doesn't mean you need to waste the material. Basically, you can cut this into small pieces again like this, and feed it into the extruder again to make the filament, and then print a new 3D objects. Actually, we have several other 3D shapes that you can see here. We just printed with the same type of recycled polystyrene filament, including a small dog model and the letters of Akron. Basically, you can print any 3D object that you want, depending on the computer design, the 3D model that you created.
All right, well, that's really cool. Okay, well, thank you, Dr. Zhu, for sharing your research with us today, and it's been really, really interesting and very informative.
Yes, thank you, John. It's a pleasure. Thank you very much, everyone.
So another way that we can recycle and reuse polystyrene, recycling code number 6, is to do an art project called Shrinky dinks. Now, this material is available commercially as shrink film. You can buy that online. So it comes in these sheets, and basically what happens is the material, as it is processed, it's stretched out in 2 directions. So it's called biaxially stretched polystyrene film. So it's stretched in the Y direction, or the Y axis, as well as the X axis. As the material cools, the molecules are frozen into this stretched out shape. And when we heat them up, they're going to return to a more stable shape. Now here's an example of just a little piece of this material. I drew a picture on it. It's a little car. We're going to put it into the oven and see what happens over the course of about 2 minutes. Now my oven is set at about 350 degrees, and we can see that it's already starting to change shape and move around in there. Essentially, the molecules are starting to relax and go into that more stable formation. We're getting close to being finished. Earlier today, I used this as a template, and I made a Shrinky dink of the Akron Zips logo. Now notice how much smaller it became after we shrank it, and it got a lot thicker as well. Thicker and more brittle. And we're almost ready with our material coming out of the oven. It is hot, so you have to be very careful. You don't want to reach in there with bare hands. Notice I have some tongs that I'm using to pull this out. So it's ready. We'll bring it out. We will set it on the table just to let it cool a little bit. And then there's our finished product. It's still a little bit flexible because it's still kind of hot, but as it cools, it will become less and less flexible. So those are Shrinky dinks, very fun. And you can also do lots of other things with them. You can cut them into various shapes, and you can just let your imagination run wild.